Then descriptive statistics, cross tabulation, we'll select gender in rows and job categories in column. Now you can see in right hand side exact, statistics, cell, format and bootstrap. There are given some options. In statistics, you can find out chi-square, correlation, co-integration coefficient. Suppose we select chi-square, then in cell, we have click on only observation. Observation, that means it will, the result will be in numbers. We will not find out the exact percentage of that figure. Suppose we have 200 something gender from under clerical and 100 from managerial. That things we can't find out. So unlike, let us run this so we will understand. See the result. Here, what is that given? First is your case processing summary. That means valid case. You have valid number of cases is 474. Missing cases is 0. That means we don't have any missing cases. If there would be any dash in between, then that would be missing variables or missing cases. So we don't have any missing cases. Then in second table, here you can see that employee gender and employment category cross tabulation. So among the male, what is the classification? Among all the male, how many were in clerical and how many were in custodian and manager? So for that, what we would like to introduce, because this is only number. For that again we have to find out the percentage, right? So that if we will find out only this number, then again we will manually do that. So to save this time, what we will do, we will go to analyze, cross tabulation, then cell. Here it was selected only observe. Now we choose rows, percentage row. That means we will see the row twice percentage. Let's see what is happening. Out of total male, that means out of total 258 males, 60.9% was in clerical and 10.5% was in custodian and 28.7% was in managerial post. Suppose within the employment category, we would like to know about the gender differences. For that, what we will do? Suppose you would like to know that out of total clerical employee, how many are female and how many are male. So that what we will do? See, all the things we are doing from the menu bar. You can, whatever program you have run, you can find out here. See. So repeatedly I will not go to analyze, descriptive, cross tabulation. I can select that from here, cross tabulation, because recently I have run the cross tab. So I will go to cell, state of rows, I will select a column, then OK. See, that means out of total clerical employee, 56.7% was female. That means female are morely engaged in clerical job when male are morely engaged in managerial post. You can interpret your results like that. Then you can see the chi-square test. That means there is strong significance relationship between gender and employment category, because you can see the differences. If male are working, male are mostly engaged in managerial job and female are mostly in commercial employee, then definitely there is differences. We can't say that there is no relationship between gender and employment, because there is relationship between gender and employment category. If gender will change, then employment category has to be changed. So here you can see there significant SC Here 0.00. Pearson's chi-square value is 0.000. If this value is less than 0.05, that means your null hypothesis is rejected. That means your both variables are significantly related with each other. There is significance relationship between these independent and dependent variables. But if this value is greater than 0.05, that means there is no any relationship between gender and employment category. So like this you can run your cross tabulation. This is the simple analysis anyone can use. Also, for this no need any advanced modeling or less things. Then now I'll show you how to report your variable. So suppose we have the beginning salary. We have the beginning salary, and we want to know about the average beginning salary by job category. For that, what we will do? You will go to analyze, then compare mean. Compare mean. Here you can see independent and dependent variables list. What would be our independent variables? What would be our independent variable? Any guesses? Income or employment category?
Employment category independent.
Employment category is our independent variables, and
income is dependent.
Current salary or beginning salary, anyone you can take. Suppose beginning salary. Beginning salary is our dependent variable. Then again in the right side you can see two options. One is option, one is bootstrap. So basically we use the option. When you will select an option, you can see here there is a number of statistics given. Mean, median, group median, sum, minimum, maximum, range, first, last, variance, kurtosis. All the statistical information given. Suppose we want the mean and number of cases and standard deviation. Only three information we want, and you can also here you can check the test of linearity and ANOVA table. Then continue. Then okay. I think why this is happening? Any guesses? Because we have taken here the employee category. By mistakenly, instead of employment category, we have taken employee category. So you can see there is a number of 474 employee category. It will be difficult, and we don't have information about ANOVA. So what we'll do, we correct our variable's name. We'll select job category, then okay. Now you can see here. See this table means average salary, average beginning salary of the clerical post. Those who were in clerical position, their salary was comparatively low from the employee engaged in manager. Obviously, it is a real fact that manager is getting more salary as compared to clerical. That things we can identify here in our table. So here given number of cases and standard deviation. Then in ANOVA table also you can, when you are talking about ANOVA, basically we use the F statistics and significance review. These last two tables is more important for ANOVA table. But here our focus is only on average mean by employment category. Like that, we'll is among the employment category, gender and employment category and minimum average mean of beginning salary. Simultaneously, we would like to see the three variables. Then what we'll do? Go to mean. Here you can see that we have selected independent variables is our job category. That means employment category. We'll go to next. In next, we'll select gender. Let's see the data. Now you can see among the clerical, what is the average mean for male, average beginning salary for female. Here also you can see the differences. Male salary of male is higher as compared to female. But in custodial, almost equal. In custodial only male are working, no female. And in managerial post also salary of male are higher than female. Like that you can do your average mean. Okay, now I'll explain how to record a data. Is it clear up to descriptive statistics? Any doubt? Okay. Then should I continue for recording, how to transform, how to compute? Okay. Okay, now suppose we have the information about beginning salary in continuous form. Let's see our data. See, beginning salary. Beginning salary in its numeric form. Suppose you would like to categorize this beginning salary in three groups. How will you do that? For that, first we have to find out what is our maximum value and what is our minimum value. From descriptive, we will find that we have already this. Then our minimum beginning salary is 9,000 and maximum is 79,980. So we'll give a range 9,000 to 20,000 is one group and 20,001 to 50,000 is one and 50,000 above is one more group. So for that we'll go to transform. See, here we have two forms. Record into same variables, record into difference variables. Record into same variables means you are converting the data in same variables. Suppose you will record into the same variables in our beginning salary, then our actual data will be replaced into our transform form. So in that case, we will not identify our actual data. So that what we will do in this case, we will do record into difference variable, because for me we need the actual number of beginning salary. So record into beginning salary, record into difference, and then record into beginning salary. Select. Here in output variable you can see name and level. Name means what variable's name I would like to give in our new data, means new variables. Suppose cell begin code. Then here given record into beginning salary. Then change. Now you can see here in middle box that cell begin is converted into begin underscore code. Then in the middle box at the down you can see that old and new values. I will select on old and new values. Then here given values, system missing, system or user missing, range. What I will do? 20,000. Lowest through 20,000. 20,000. In new values name 1, then 8. Then in second code I will give range, because below 20,000 I have one code. Lowest through 20,000 is my one code. Then 20,001 1000 is my new code 2. Then highest through 50,000 1. See. If you have make any error, then you can correct here. See, in which code I will select, it will be visible here. Then continue. Then okay. See, in our output file, at the end of, you can see a syntax. This is the syntax. You can save this in your syntax file. Suppose I have done some error, then I can correct here directly and run the program. This is one of the process through which you can save your syntax file. Otherwise, directly you can create syntax file. Record here you can see the test. Okay, then test. You will select test, then your syntax will test here. Automatically it is test in your syntax file. So like that. Now we will see our data view, what happened in our C. In our variable view, you can see one more variable added here, beginning underscore code, record into beginning salary, but I haven't given level here. So in values, I will give, before that I will see the frequency. See, our beginning salary has classified in 3 categories, 1, 2, 3. But it's showing numeric form, 1, 2, 3. But we don't know what is 1, what is 2, what is 3. For that, we give values in here. 1 less than equal to 20,000. Add 2. 20,001 to 50,000. Okay. Then 3 greater than equal to 50,000 1. Add. Okay. Now we will put it in 0 because we don't want 2 decimal number. Now we can see. We will run frequency and see. Now we got the classification less than 20,000, 20,001 to 50,000, then more than 50,000. More than 50,000, only 3 individuals are come under this category. So that accordingly we can decode our variables. Like that, you can also suppose we would like to club these 2 variables, 3 and 2, because greater than 50,001 is very minimal number. 3, only 3 numbers of individuals is come under that category. So for that what we'll do? Because we don't want this variable, we would like to club code 3 into code 2. In that case, we'll go to transform, record into same variables. Then record, we'll select the variable's name, old to new. 1 would be in 1 and 2 is 2 and 3 would be 2. Or you can just remove this, and here you can write highest through 2 is 2. Now we will see the frequency. Now our more than 50,001 has clock with 21,000 to 50,000. But we haven't changed the values level. So for that what we'll do, we go to variable views, and here we will remove last one, and here we edit this. Greater than equal to change. Okay. Like that you can record your variables. Then you can compute new variables. How you can compute new variables? Suppose compute variables. You can create any new variables through computed variables. Like log transformation, you can convert log transformation, any arithmetic data any arithmetic format you can use here. When you will select here in statistic, you will find mean, median, mode. Then in arithmetic, you will get log of 10. Suppose log beginning. Suppose we need log transformation of beginning salary. For that, what we will do? We have given our variables name, target variables is log begin, then log 10. See, log 10 within bracket, it has come a question mark. So in this question mark, we put our variables name, which variables we would like to convert in log transformation. Which variable we would like to log transformation? Obviously our beginning salary. So here we select our beginning salary. Then okay. Now we will see our data view. See, we have a new variables name here, log beginning. When you would like to do some logistic regression analysis, log format, then in logistic regression analysis, you need your dependent variables in log transformation. That's why we have to convert our income or salary in dependent variables into log transformation. So that here we have transformed our beginning salary into log of beginning. Is it clear? Okay. Like that, in analyze, compare mean, you can also run one sample t-test. Suppose you would like to compare the mean in a sample, then you can run one sample t-test, then independent sample t-test, pair sample t-test. If you have two variables and you would like to see the mean variations, then you can run it. Then correlation. You heard about the correlation, bivariate and correlation, partial correlation. That also you can compute here. Then regression, linear regression, then partial least square, binary logistic regression. In binary logistic regressions, your dependent variables must be in 0 and 1 format, binary format. Like, suppose I have classified beginning salary into two categories. Suppose core and non-core. Core and non-core would be my dependent variable, then core would be 0 and non-core would be 1. Like that, your data should be framed in binary format, so that only you can run the binary logistic regression. Multinomial logistic regression, when your dependent variables is more than two categories, then you can run the multinomial logistic regression. Then probit, nonlinear, weightage, all these things you can do from SPSS. Then You can also multiple response analysis. Suppose you ask someone that what is the preference. One individual has simultaneously answered two questions. Yes, in my household we have TV and also fridge. That means your answer is in multiple. Your question is in multiple and your answer is in multiple type. So in that case, you can do multiple analysis, multiple response analysis. Then forecasting. Someone has asked about how we can analyze time series data. For time series data, we use mostly for forecasting. So here option is given in forecasting. You can run that with the help of this. And one more simple technique I would like to share here that you don't know anything about SPSS. Don't think that someone will help you to teach you. Wait, any question? Do you have any query? Okay. Suppose you don't have any expert, you don't have taken any training program on SPSS, but you have SPSS software. How you can learn from yourself without any expert, without any guidance? How you can learn? Simply, whatever we have learned, I'll just show you the simple way to guide to yourself. No need any guidance. For that, suppose I don't know how to run frequency. What is frequency? I don't know. Frequency is very simple. So when I will open this, here you can see it at the down. Reset, cancel, help. I will select on help. Simply I will select on help. When you will select on help, let's see, your help window will open where all that instruction is given. For that is not required internet. It will open even if you don't have internet facilities in your laptop. See, when I click on help, I find a number of suggestions. Wait, there is some issue here. See, now you can see I got my answer because I don't know what is frequency, how you can run it. You can read this instruction. These features require the statistics dash option. The frequency procedure provides statistics and graphical display. What is the significance of frequency? That is given here. I would like to see furthermore that you will click on show me. When you will click on show me, then step by step, see here step by step all the information given. Then you will go to next. See in left side all that technique given here. Wait. Like here frequency, then partial correlation, bivariate, GLM. I would like to know about the linear regression. I just click on linear regression here. You can see that one window is open here, linear regression. Next, here given the mathematical equations. Means what is, you know that y equal to alpha plus beta 1x. If you have one independent or one dependent variable, but if you have one dependent variable and more than one independent variables, then y equal to alpha plus beta 1 x1 plus beta 2 x2 plus beta 2 x3, and at the end you have the error term, which that is ui or ei. So this is conceptually given. Then when you will go to next, then you can see what is the significance of regression analysis. Then using linear regression, see here, see this line. The last line, information concerning different makes the model of car is contained in car cell.sav. That means for this example, for to run the regression analysis, you can use the dummy data which is already given in SPSS. That file name is car.cell.sav file in sample. We'll click on sample file, then our car_cell file will open. Then we'll go to next. See, running the analysis, analyze regression, then linear. Here, this is linear regression. Then next, in linear regression, what would be your dependent variables and what set of independent variables? In right side, it has given the description. Log transformation of cell, like log transformation of beginning salary we have taken in our employment data. In your cell_car data, there is a variable name log transformation of cell. Then next. Then next, estimates, model fit, then part of partial correlations, correlative diagnostic, all these things. Then next. Now you got your results. This is interpretation of first tables. You can see it is highlighting the F statistics and significance value because and R square value. But in these tables, it is given only F and significance data. Then in next tables, in your model, because this is the model, you can see that in R square is our 0.486. That means our model explained that about 49% differences. So mostly you have to interpret the R square value when you have the linear regression. Then see, in these tables, you will get the significance value as well as beta coefficient, beta coefficient, that is the beta 1 x1, beta 2 x2. So we have a number of independent variables like vehicle type, price in thousands, engine size, all these are our independent variables. So beta coefficient, first one is our constant, beta is our constant, then second column is our standard error, third column is our beta coefficient. Beta coefficient is basically the beta 1 x1. That means slope of our vehicle size is 0.293. This how much, if there will be how much changes in your independent variables, what is the change in your independent variables? And here you can see the significance relationship. So what are the independent variables are significance with the dependent and what are the variables are not significant? From in your last column you will find that. And the description of all these things is given in right hand side. See here, given the information. Then we'll go to next. See, it is explained step by step. Then correlation coefficient, then eigenvalue. All these things not require so much for interpretation. Mostly we interpret our R value and beta coefficient of each individual variables in our table. No need to put all these eigenvalue, condition index, all these things not required to given in your thesis. So like this, you can learn every model from SPSS without any help. I think this would be helpful for you. Is it okay?
Yes, ma'am.
Okay.
Yes, ma'am. Ma'am,
SPSS is a vast field. Yeah. We have already crossed our time.
No, madam. Already 10, maybe. So you can take some questions from the participant within 5 to 10 minutes to wind up. If there is a question, then we can go for the question, or otherwise we can wind up.
Okay.
Thank you. Anybody having any question, you can ask.
Yeah. They have written some question here. Here, how much is the cost SPSS and how can we learn from the software without extra help? Okay. Like that from if you have any cracked version or a pirated version of SPSS, then you can learn it. And in each model, you will go to help button because everywhere you will get the help button, and you will select on help button. All that procedure will be you will find out from there. Then how No. Actually, SPSS is too much of costly. So that on replace of SPSS, you can use to R. Nowadays, R is very much popular, and everybody can use that R software at free of cost. So for SPSS, it would be some costly, maybe 50,000 for individuals user or 1 lakh. That depends on users. Any other question?
Thank you, madam.
Sorry, actually, this is not the course for 2 hours. For this, it requires some 1 week, 12 days. So I try my best. Yeah.
Thank you, madam, for your valuable presentation.